Okay, minute hand on a clock is, how long is that? 4 inches. Okay, go please. Okay, so this is known as the sector right there, and they want to know how fast that sector is changing. So you need to know the formula for a sector. Okay, formula for a circle is pi r squared. Sector is only a portion of this circle. What portion of the circle is this? Well, it depends on what the angle is. What is the angle? We'll call the angle theta. Okay, all that over 2 pi. Does that make sense? 2 pi is all the way around the circle. Okay, theta is the angle. That's the radian. This is this part right here. That's my theta. Okay, and then all the way around is 2 pi. Of course, they're going to cancel. And in this situation, my r happens to be 4 because that's the radius. So that turns into theta over 2. Okay, and for those of you that like, okay, we'll keep theta. Theta over 2. And this is going to give me 4 squared, and that simplifies to the area is equal to that's 16, so 8 theta. Alright, that is the function we're going to use. We're going to find the area of this sector. That's the area of the sector. So dA dt, we're taking with respect to time, is equal to 8 times the derivative of theta, which is the theta dt. Alright, so Kara, you got to this point, you couldn't figure this out. Okay, it's a minute hand. Okay, so to go all the way around the circle, how many minutes does it take? 60. So d theta dt, okay, dt is going to be 2 pi over 60. Okay, so that is going to be pi over 30. So we're going to put pi over 30, 8 times pi over 30, and that reduces to 4 pi over 15. Okay, this would be inches squared per minute. Got to make sure you put the units. Alright. You were almost there. Oops. Okay, the next one is 25. So let's take a look at the 25. All right, Joey. Oh, you need to know that. You're big boys and girls now. You're in calculus. You're required to know all this stuff. Yeah. Okay. 25. Let's see. Let me pick on somebody. Teresa, get a book. Borrow one. Fast. Okay, you're going to read this for me. Okay, 25. When I tell you to stop, I want you to stop. Don't go on, okay? Ready? Go. Stop. Conical water tank. Draw a picture. Go. Okay, stop. Every time I get information, okay, I write it down. Go. 24 foot high, so from here to here is 24 feet. Go. Okay, stop. 20 feet cubed per minute. Since it's cubed, it means this is changing in volume with respect to time. Go. Stop. How fast is depth of the water? It means they want me to find dH. We'll call h the height or depth. I don't want to use d for depth because then it'll be dd dt. It's a little confusing. So dH dt. Find dH dt. Go. Okay, when height is equal to 16 feet. Alright, so I listed all the information that I have, and I know it has to do with the volume of a cone. That means I need to know the formula of the volume of a cone. Volume of a circle is pi r squared. Volume of a cylinder is pi r squared h. How many cones are in a cylinder? There are 3 of them. So therefore the volume of a cone is pi thirds r squared h. Okay. Now, I have 3 variables, and that's really important when you take derivatives because this is a single variable calculus, so we can't deal with that many variables. If I take the derivative of this as is, I'm going to get a dv dt, I'm going to get a dr dt, I'm going to get a dh dt. Okay? If I have the information, then I'm good to go. dv dt, I have that, so I can keep my b in there. dH dt, I'm trying to find that, so I need to keep my h in there. There's nowhere here where you have a dr dt. That tells you you need to get rid of the r. Okay, we're going to go to geometry to get rid of the r. This is some random r, radius, and this is some random h, height, in a cone. Now, this is a right triangle. This is a right triangle inside of a right triangle. These are similar right triangles, so that means they are proportional. So the radius is 10 to the height, which is 24. This is going to be the same thing for any random radius and height. So the proportionality is going to stay the same. Having said that, we can reduce this and solve for r by multiplying both sides by h. So this will turn into a 5, this will turn into a 12. So I'm going to get 5 over 12. Okay, h is my r. I'm going to take that information, I'm going to put it right there. So when I do that, I'm going to get pi over 3, okay, 5 over 12 h, quantity squared, times h. Just made a substitution. So I can clean this up a little bit. This is 25, so I'm going to get 25 pi on the top. Okay, this is 144 times 3, so I'm going to leave it as 3 times 144. I'm doing that because of my mathematical maturity. Okay, that's h squared times h, which is h to the third. Because I know where I'm going with this, that's why. Alright, when I take the derivative of the left-hand side, I'm going to get a dv dt. When I take derivative of the right-hand side, please don't use product rule here. This is just a coefficient right there. That's just a number. Okay, so you're going to get 25 pi over 3 times 144. And then when I take the derivative of that, then I have to use the chain rule, which is 3h squared times dh dt. See, the 3's reduce off. That's why I did that. Alright, now what I have is dv dt. I have 20. And I have 25 pi over 144. Okay, h, I have a value for that. That's 16. So that's going to be 16 squared on the top. Okay, and then I have a dh dt. I'm solving for dh dt. Okay, put 200 here. Meant to put 20. Okay, I'm solving for dh dt. So that means I'm going to divide by this. That means it's going to multiply. So my dh dt will look like this. Okay, 20 times 144, all that over. Okay, 25 pi times 16 squared. Since this is height, I had to put units in there, and the units are going to be inch, okay, per minute. Okay, but you do have to write, every time you ask a question, you have to write a short sentence, and the short sentence would be, the height is changing. Use the word changing, then you don't have to worry about if that's positive or negative. You can put down whatever that you have right there. Okay? Height is changing, and you can write this down as is. If you choose to simplify that, do it at your own risk. You're not, some of you haven't learned your lesson yet. Okay? You're not very good with simplification, okay? And you're going to lose points. Leave it alone. Alright, 25, so let's go to 26, 27, 28, so 26. Alright, let's see. Amy, you have a book? Oh, Jasmine, you don't have a book. Okay, read 26 for me. You borrow her book? Okay, stop. That means volume is changing because it's cubic feet, 8 feet cubed per minute. Okay? Okay, stop. I gotta draw a picture. Conical pile. Alright, go ahead. Okay, so I'll call this my radius. Okay, call that my altitude, which is my h, and that's my r. And it said h is twice the radius. Okay, go. Okay, stop. They want me to find dh dt. At the instant means when. Go ahead. Okay, when the height is equal to 6 feet. Looks like the same type of problem, right? Okay. Alright. So my volume is equal to pi thirds r squared h. Again, I have too many variables. dh dt is okay. dv dt is okay. I need to get rid of the r. Okay, I am going to go r is equal to h over 2. So I'm going to put that in there. So pi over 3 and then h over 2 quantity squared h, which is going to give me volume is equal to pi over 12 h cubed. I'm going to take the derivative of this now. I get dv dt is equal to pi over 3 h squared dh dt. Plug in the information that we have. So my v dv dt is 8, okay, which is equal to pi over 3. My h is 6 squared. Okay, that's dh dt. So my dh dt turns out to be 8 times 3, all that over 36 pi. And this will be in terms of feet per minute. Again, short sentence. Yes, sir. 3 over 12. You mean right here? 3 over 12. What 3 over 12? Oh, that, yeah. That is 1/4. I can't do math either. So, this will be 4. I think everything else is okay. Change that to 4. Alright, you can leave it as is, but you do have to write a short sentence. 27. Clara, you have your book? Wait a minute. Do you have a book? Rebecca, you have a book? No. One of you doesn't have a book. Which one is it? Okay. 27, read. Okay, stop. We gotta draw a picture of a cone. You notice there's a lot of cone problems. Yeah. What's the likelihood of you're gonna see a cone problem? What's the probability? Probability is pretty good. Okay, go ahead. Okay, so diameter is this. and that's my height. Okay, and that's my d. So my h is equal to d, which is really 2r. Okay, so I have dh dt. Okay, 5 feet per minute. Okay, go. Okay, so they want me to find dv dt. Okay, volume is changing when h is equal to 10 feet. Okay, so same problem all over again. Volume is equal to pi over 3 r squared h. I have dv dt, dh dt, and h, so get rid of the r. So r is equal to h over 2. So volume is equal to pi over 3 h over 2 quantity squared h, and volume is equal to pi over 12 h cubed. Okay, and volume is equal to pi over 3, right? All right. There it is. That's the derivative, dv dt. Plug in what we have. Okay. I have a pi. Oh, pi over 4. H is 10 squared. Dh dt is 5. So dv dt turns out to be, okay, all this feet per cube per minute. Volume is changing. That's 100, that's 500 pi over 4. So dvd. What's that? 500 pi over 4. 120. 125. You don't have to simplify. That's it. Alright, 28. Moving on. 28. Ming Yu, do you have a book? Okay. Whose book is that? Alright, then you get to read. Number 28. Okay, stop for a second. dv dt is equal to 10 feet cubed per minute. Okay? Okay, so the bottom radius is half the altitude. Same problem over and over. Ooh, this is the circumference, dc dt, okay, when h is equal to 8 feet. There's a little twist in this. Just like there was a twist in that extra credit problem. You have to do two things. Okay, so my volume formula is, okay, pi thirds r squared h. Obviously we're going to replace that. Okay, so we're going to have v is equal to pi thirds. Should I replace that? 6 1/2 dozen the other. I think which way should I go? Should I replace that or should I replace dh dt? Alright, that's alright. I'll just replace that. We'll go that way. So since we've been doing that, squared h, v is equal to pi over 12 h cubed. Okay, when I take the derivative of this, I get a dv dt is equal to pi over 12 3h squared times dh dt, which simplifies to pi over 4 h squared dh dt. Right. Well, we have a number for this that's equal to 10, because that's my volume, change in volume. Now, the problem is we're looking for dc dt. So we need another formula. Circumference is pi 2 pi what? R. If I take the derivative of this, okay, I'm going to get dc dt, but I'm also going to get dr dt. But I'm not looking for dr dt. I need, dh dt. So I might want to switch this. That's why I was debating which way. You'll get the same answer, okay, because you're going to get dr dt, and if you switch everything in terms of r here, okay, then you can go a different way and get the same answer. So I'm going to switch this off to 2 pi, okay, h over 2. So they're going to cancel. My circumference is pi h. So, yes. Yeah, we could have. And then you could have done that too. Yeah, sure. You could have taken this one right there, and then said r is equal to 2 pi c, and then plug that in, write everything in terms of r, and then replace that. Yeah, you could do that. Yeah. So this is dc dt, which I'm trying to find, which is equal to pi times dh dt. So when I solve for this dh dt, that turns out to be 1 over pi dc dt. Okay, so now that right there, I can take that and put it right there in terms of dh dt, and I have 8 there for my height. So so I have a 10 is equal to pi over 4 8 squared. Instead of dh dt, I am writing that, which is 1 over pi dh dt. Alright, so the pi's cancel. This is 64 divided by 4. 10 is equal to 16 dh dt. Okay, my dh dt turns out to be 10 over 16. Yep. Come on. It's not dh dt, that's dc dt. dc dt. Okay, so they're replaced with that. So that will turn into circumference was in terms of feet per minute. All right. So there's a couple of ways you can have gone. We've got the same thing. (29) through 34. What would you like to see? 30, 29, 32, 34, 33. That's everything, huh? You just have to sit here and watch me do it. That's all I'm going to be doing. Alright. Alright. An aircraft is climbing at 30-degree angle from the horizontal. Means that's my horizontal. Okay, I have aircraft that's climbing this way. So there's my aircraft. How fast is aircraft gaining altitude? That means that's my altitude. We'll call that y. So they want me to find dy dt. Okay, if its speed is, so that means this distance here is changing. Okay, we'll call that z. So dz dt is equal to 500 miles per hour. Okay, and this is 30 degrees. Alright, what trig function deals with that angle, an opposite side, and a hypotenuse? Sine. So sine of 30 degrees, because that angle isn't changing, that's a constant, you can put it in. Any constants you can put them in. Okay, sine of 30 degrees is equal to opposite over hypotenuse. And you can't put in, okay, any values for z and y because they're changing on me. Okay, sine of 30 degrees is good. I'm glad you don't have to draw a unit circle to figure that one out. Okay. Alright, I'm going to multiply both sides. So I can avoid the quotient rule, I'm going to multiply both sides by z. So 1/2 z is equal to y. We're going to take the derivative of this, which is 1/2 dz dt is equal to dy dt. And then we're finding dy dt, so I know what my dz dt is. dz dt is 500. So my dy dt turns out to be 250 miles per hour. As you can see, this is where calculus comes in handy, because things are changing. You can't do any of this stuff without calculus. Anytime that changes. Somewhere along the line, if you become a pharmacist, you'll have to figure out how fast the drug is flowing through your body. Okay, how fast the rate the drug is, going through your body into your heart. Gotta figure that out. Yeah. Okay, 30. All right, let's see. Macy, you got a book? Allison, you have a book? Oh, okay. Can't call on you. Josh, you have a book? Borrow one. Read number 30, please. Okay, stop for a second. I need to draw a boat and a pulley. Okay, go ahead. Okay, the rope is attached to the bow of the boat. Okay, so there's the bow of the boat. Okay, so that means this is 10 feet right there. Okay. If the rope is pulled to the pulley, okay, we'll call this Z. Okay, that means dz dt is 10 feet. No, 20 feet, right? Okay, 20 feet. And this is where you have to be careful. This is 20 feet per what, minute? Foot per minute? Okay, now here's the problem. And they didn't tell you this. If this is the distance Z, when you pull this, is Z getting smaller or bigger? That means this gets a negative. Got to account for the change. Okay. Derivatives of vectors. Vectors have not only magnitude, which is 20, also has a direction. Okay, which is the negative. Okay. All right, go ahead. Okay, stop for a second. I'll call that X. So find, they want me to find dx dt. Go ahead. Okay, so when z is equal to 125 feet. Alright, so what kind of a mathematical formula do you think we're going to deal with three sides of a right triangle? Pythagorean Theorem. X squared plus 10 squared is equal to z squared. Okay, if we take the derivative of this, we're going to get a dx dt, dz dt, so we don't need to manipulate anything. We can take the derivative as is. So we're going to have a 2x, okay, plus the derivative of that. And what is the derivative of that? Don't tell me it's 2 times 10. Thank you. 0. Okay, 2z dz dt. Oh, I have a dx dt also. Oh, don't lose that. Okay, I'm finding dx dt. Okay, so I have a 2. I don't have anything for x. Dx dt. I'm finding that. And I have a 2 times z, which is 125. Okay, and then dz dt, which is 20. Okay, I'm home free if I can find out what that x is. Okay, so at that instant, see, now I can put in 125 for the z. I can't put it in initially because, okay, this is one of the mistakes you guys make all the time. You'll say, oh, I already know what z is. I'm going to put that in. No, z is changing, so you got to account for that change. Okay, so you cannot put that in. But I can put 10 because this pole is not changing, is it? It's a constant, so you can put in any constants, but you can't put in anything that is changing. You got to account for that. Alright, so we're going to use the Pythagorean theorem. So I'm going to get 10 squared plus x squared is equal to 125 squared. Okay, so this is 100 plus x squared. And someone calculate 125 squared for me, please. I don't think it. I'll bet you my paycheck is not 525. $15,620. Thank you very much. Yeah, I'm not very good with numbers, but it's not 525. So 15525 when I subtract, right? Okay, my x is equal to rad 15525. So, right here, I'm going to put rad 15525. Am I going to actually take a square root of that? No. If it's not a perfect square, okay, no sense in taking square root, getting decimals, because that would be approximation. So basically my dx dt, which I'm trying to solve, will turn out to be 2 times 125 times negative 20, all that over 2 times rad 15525, and this will be in terms of feet per minute. That's 30. Let's go to 31. Irvin, you have a book? Good. Sarah, you have a book? Devin, you have a book? Chelsea, you got a book? Jessica, you have a book? Sarah, let me see your book. Devin, let me see your book. Okay. Alright. Let's see. Lily, you have a book? Hold that up for me. Joey, you got a book? Okay. Alright. Found one. Read number 31. Shh. Joey's trying to read. Okay. So we still have this boat. Okay. And this is 10. And this is Z. And this is my X. And so they're asking me how fast must the rope be pulled. So that means they want me to find the rate of change of dz dt. Okay, at the rate of 12 feet per minute. Okay, so that means dz dt is going to be 12 feet per minute. Okay. If we want boat to approach, oh no, sorry, no, you got it, gotcha. Nothing. They want me. Okay, they're saying if we want the boat to approach the dock at the rate of 12 feet per minute, that means they want me to find dx dt when dx dt is 12 feet per minute. So that will be negative because the x is going to get smaller. Okay, at the instant when 125 foot of the rope is out, when z is equal to 125 feet. Okay, same nonsense. X squared plus 10 squared is equal to z squared. Take the derivative of this, which is 2x dx dt is equal to 2z dz dt. We're looking to find that one. My dx dt is negative 12. Okay, and I have a 2, and at the instant, was that 125 last time too? Yeah. So we found my x to be what? Radical 15525. Okay. All right. Times. Where do I have? That should be a minus. So that would be minus minus 12 is equal to 2 times z, okay, which is 125, and that's my dz dt. So my dz dt turns out to be 2 times rad 15525 times negative 12, all that over 2 times 125, and that will be in terms of feet per minute, and make sure you write a short sentence. As you can see, this is easy. I mean, it's not that hard if you know how to do it. Alright, that's the trick. Learn how to do it. 32. Okay, there's a historical significance to this problem, so I'm going to share that with you. There are certain problems that never show up, rarely show up, and then sometimes the College Board says we're never going to put this problem ever again. One year there was called a trough problem. The horses were coming in drinking water out of their trough, and they were drinking at this particular rate. How fast is the height of the water in the trough is changing? Well, pretty much everybody blew up on that free response question. And then College Board swore they will never put another problem like that. About 3 years ago, there was another problem. Okay, the 50% of the kids on that 50% of the kids in the United States on that problem got 0 points out of 9. Okay, they probably will not put that problem ever again. Okay, this problem here, shadow problem, shows up once every 10-15 years. Okay, and that one year I didn't cover this particular problem. Okay, and it was so easy, and then my kids came back, oh, Miss Mai, there was this shadow problem, we didn't know how to do it. It's so easy. Okay, if you just cover it, you get the idea. Matter of fact, this will also give you a hint on the extra credit problem that I've assigned. It's similar to the extra credit problem. Okay, so you might want to pay attention if you want to get the extra credit. Okay, all right, having said that, let's see. Alan, you have a book? King, got a book? All right, back to you, Teresa. Okay, 30. 31. Oh, 32, sorry. Okay, stop. I gotta draw a man 6 feet tall. Okay? And the walking at 3 foot per second toward a street light. It draws street light. Okay? And I'm going to call this distance x. So that means my dx dt is changing, and that's negative 3 feet per second. Go, please. Okay, so I got my street light, and that is 18 feet. Okay. Yes, ma'am. Why is it negative? It is negative because if I call this, that's a good question, and make sure you know, the rest of you are paying attention, okay? That distance is x. Whenever something changes and gets smaller, it will always be negative. When something gets bigger, it's going to be positive, because that distance, he's walking towards the street light, so therefore the distance between the person and the light is shrinking. Good? Alright. Go ahead, Teresa. Ooh, wow, look at that. Shadow length. Only the shadow knows. Okay, this is the shadow length. We'll call that y. Okay, so they want me to find dy dt. Okay, and then that's part A. In part B, what is that? How fast the tip of the shadow? Wow. Okay, so we know this is the tip right there. Okay, we're going to find the tip in a second, but think about this. This person is moving in this direction. That means, will the shadow get smaller or will it get bigger? It's going to get smaller. Okay, the shadow, if you get closer to the light, it's like sun is right above you, right? The shadow's going to get smaller. So this is going to start shrinking. That means my dy dt is going to turn out to be a negative. It better be. Okay, now this little tip right there is influenced by two things. The shadow is shrinking, and that distance is shrinking. So that is going to be affected by both of those. Okay, both of those. Okay, so how fast this thing is going to move depends on the shrinkage of this and how fast you're moving. Okay, not just the shadow itself. Okay, having said that, okay, this is a right triangle. This is a right triangle, and they are similar right triangles. So therefore, what 18 is to x plus y is going to be, well, 6 is to y, because that's 6. Similar right triangles. Okay, let's clean this up before we do anything. So let's cross multiply. I get 18y is equal to 6x plus 6y. Okay, clean it up some more. I'm going to get 12y is equal to 6x. Okay, we have dx dt. Okay, and we're finding dy dt, so we're going to take the derivative. 12 dy dt is equal to 6 dx dt. Plug it in. Okay, I get 12 dy dt is equal to 6 times negative 3. So my dy dt is equal to negative 18 over 12. And that reduces to what? Negative 3 over 2. And that will be in terms of feet per second. So this is the shadow. The shadow is shrinking at negative 3 halves foot per second. Okay. As you can see, this is an easy problem. But if you've never seen it before, you would know how to set it up. Okay, so always keep in mind the proportionality of the right triangles. They do show up. Now, having said that, now the tip of the shadow, we'll call that dt, big tip. Okay, The tip of the shadow depends on two things. How much this is changing, how much this is changing. That's like this. Let's say that someone's walking towards, let's say Carl is walking towards the door, and I'm mad at her because she's been sticking things on my clothes all the time, and I get behind her and I push her into the door. Okay? So therefore she's going to be going faster. So dt is going to be my dx dt plus dy dt. That's my dx dt, change in that, and that's change in the shadow. So dx dt is -3, okay, plus dy dt is -3 over 2, and that's going to give me -9 over 2 feet per second. And the tip of the shadow is changing, short sentence, tip of the shadow is changing by -9 over 2 feet per second. Alright. 33. Back to you, Jasmine. Okay, so let's put a beacon out here. One revolution every 10 seconds. That means my d theta dt is 2 pi every 10 seconds. Okay, that's one revolution. Go ahead. Okay, so right there, there's my straight shoreline, and this is 4 kilometers. Okay. Okay, how fast? So this beacon is here, okay, and it's going to do that, okay, and it's going to do that, it's going to do that. Okay, so they want to know how fast, okay, is the beam moving. So if I were to redraw this, okay, it will look like this, okay, when that makes 45 degrees to the shoreline. Okay, and that is 4 kilometers, and d theta dt, okay, we'll call that theta, so d theta dt is that. So we'll call this x, and we want to find how fast is that moving there. So we want to find dx dt. Okay, so this is tangent, because we're dealing with opposite and we're dealing with adjacent. So we're going to go tangent of theta is equal to x over 4. Okay, and this is, okay, when theta is equal to 45 degrees. Okay. Alright, so 4 times tangent of theta is equal to x. Take the derivative of this, there'll be 4 times what's the derivative of tangent? Secant squared theta d theta dt is equal to dx dt. Alright, I have a 4 times secant. Okay, so if this is 4, this is 45 degrees, what do you think the x is going to be at that instant? It's going to be 4. Okay, if that's 4 and that's 4, what's the hypotenuse is going to be? 4 rad 2. Okay, so that's 4 rad 2. So secant is what? 1 over cosine. So cosine would be 4 over rad 2. So be this one will be 4 times. That's going to give you 4 rad 2 over 2 over 4 squared. Are we okay with that? That's my secant. D theta dt. What's my d theta dt? Which is 2 pi over 10, which is my dx dt. Okay, 4 is going to, the 4 is not going to cancel. Got to square that. So I'm going to have 4 times, that's 4 times 2, or 16 times 2, which is 32, all that over 16. Okay, times 2 pi over 10, which is my dx dt. Okay, so this and this reduce, I get it 2. Okay, and so this and this reduce, I get a 5, and I'm going to get 8 pi over 5 is my dx dt. And this is in terms of kilometers per second. So my dx dt turns out to be, okay, 8 pi over 5 kilometers per second. All right, herein lies a problem. I should have a negative answer. So where's my mistake? Because my x is getting smaller. Where's my mistake? Because you're going to make this. Come on. It's right in front of you. Killing me. Huh? I got to get a negative answer. Okay, this cannot be positive because this side is shrinking, right? There's something I did not do that gave me a positive answer. D theta dt is negative because when that light is going, my angle here is shrinking, isn't it? It's getting smaller. Okay, that angle is getting smaller, so that should be negative, and that'll be the negative. Okay, and therefore I'm going to get a negative answer. Okay, so make sure you account for that. Okay, easy to overlook that. All right. Okay. Last one, 34 in this section. Let's see, who's next? Josh, back to you. 34. Okay, hang on a second. This is an aircraft. Okay. And this is Caro here in her aircraft. Okay. Okay, we'll call that this. She's going someplace. We'll call that x. Dx dt is negative 600 miles per hour. I put it negative because that's shrinking. Go ahead. Okay, here I am. Okay, and I got my missile, handheld missile. Okay, I'm firing my missile. Okay, and we'll call that Y. Okay, go ahead. Okay, and go ahead, keep going. At the end. Okay, when x is equal to 2 miles, go ahead. Okay, y is equal to 4 miles. Okay. All right, my missile's flying now. I got Caro in my sight. So 1,200 miles per hour. Okay. Oh, for me, that means I got to figure out what that is, how fast that's changing. We'll call that z. That's the distance. So they want me to find dz dt. And guess what? when dz dt is equal to 0, what's going to happen? Yep, Caro's done. Okay, no more picking on Mr. Subaya. Okay, alright, so what kind of a mathematical function deals with three sides of a right triangle? Pythagorean Theorem, so x squared plus y squared is equal to z squared. Yes, sir. Oh, that better be negative 2, huh? Thank you. Yeah, that better be negative 2 because that's shrinking. Okay, otherwise we'll never get Carl. Alright, so I'm going to be going the other way. My missile's going the other way. Alright, I'm going to take the derivative of this. I'm going to get 2x dx dt plus 2y dy dt is equal to 2z dz dt. dx dt I got something, dy dt I got something, dz dt I'm trying to find. X, y, I have x and y. X is 2, y is 4. So how do I find my z? Pythagorean Theorem. So that's going to give me 2 squared plus 4 squared is equal to z squared. So that's going to give me 4 plus 16, which is equal to z squared. So z is equal to rad 20. Alright, let's plug it in. So 2 times negative 600 plus 2 times 4 times negative 1200, okay, is equal to 2 times rad 20, okay, times dz dt. Okay, so my dz dt, therefore, that's what I'm solving for, turns out to be, okay, this is 4 times negative 600, just trying to save some space, and plus 8 times negative 1200. All that's going to be divided by 2 over rad 20. Okay, and this will be in terms of what, miles per hour. Always put units and a short sentence. Now, what kind of answer am I getting? Positive or negative answer? Does it account for my changing z distance, getting smaller? Okay. Those are related rate problems. Make sure you know how to do them. There'll be 1 out of 6 questions on the AP test. There'll be more than 1 on tomorrow's test. Okay, do you have any questions on implicit differentiation? Just one? Alright, page 217, 11 through 27 odd. We got about 10-15 minutes, so odd and 37 and 39. What would you like to see? 19. What else? Is that it? And 25. 19 and 25. Let's see what we got. 19. 19. Okay, 19. I have a tangent cubed of x, y squared plus y is equal to x. Okay, we're taking the derivative of this function with respect to x, not t anymore, it's with respect to x. That means when you take derivative of x, it's going to turn into a 1. When you take derivative of y, it's going to be dy dx. In short way, we write that as a y prime. What is my outermost function here on this side? Cube. So it would be 3 tangent squared of x, y squared plus y. What's my next innermost function? So I just took the derivative of that. What's my next innermost function? Tangent. So I got to take the derivative of tangent, which is secant squared. I leave inside alone x, y squared plus y times. Then I got to take the derivative of the inside there. What kind of rule do I use? Product first times derivative second, 2y times y prime plus second, which is y squared. And when you take the derivative of x with respect to x, it's going to be 1. Okay, plus derivative of y, which is y prime, okay, is equal to derivative of x, which is 1. Okay, I have a y prime here, y prime there, and I got all this garbage right here in front of that multiplied. What do I do with the garbage? Okay, I divide by the garbage. So I have a 2x y prime plus y prime plus y squared. I just rearrange these, and then 1 over, I'll just call that garbage for right now. Okay, you can do that as long as you bring the garbage back in. If you take garbage out, you got to bring garbage back in. Okay, can't leave your garbage out. Okay, I'm going to subtract y squared, factor out of y prime, so y prime is equal to 2xy plus 1. Okay, and then that's equal to 1 over garbage minus y squared. I'm going to divide everything by this, so my y squared, y prime, is equal to 1 over garbage minus y squared, all that over 2xy plus 1. Okay, like I said, we've got to bring the garbage back in, so we're going to bring it back in, which is going to go 3 tangent squared tangent squared of x y squared plus y times secant squared x y squared plus y, and then minus y squared, all that over 2xy plus 1, and that's my y prime. And I know a lot of you will be tempted to simplify that. Just fight the temptation. Okay? Don't try to impress me. 25. Okay, y plus sine of y is equal to x. We are finding y double prime. Okay? So we're going to take the derivative of this. That's going to be y prime. And some teachers do it as dy dx. Okay? I do it as y prime because I'm lazy. Okay? And most math people are lazy anyway. Derivative of sine is cosine of y times y prime is equal to 1. Factor out of y prime, which is going to leave you with a 1 plus cosine of y is equal to 1. If you're going to take the second derivative, you will have to simplify as you go. That's what I'm doing right now. Y prime is equal to 1 over 1 plus cosine of y. Now you can use a quotient rule now, take the second derivative, or you can make your life easier because you know a chain rule. This is the same thing as 1 plus cosine of y to the negative 1. So my y double prime turns out to be negative 1 plus cosine of y to the negative 2 times the derivative of the inside. So derivative of 1 is 0, derivative of cosine is negative sine of y times y prime. Only thing is, you can't leave that as is. You have to always replace the y prime, whatever y prime stands for. Everything else you can leave it as is. So I'm going to leave that alone. Okay, I have a negative times negative sine of y times my y prime, which is 1 plus cosine of y to the negative 1. Do you want to clean it up? You can. You don't have to. And one more. What was that one? 20 what? Is that it? 37? 37? Is that what you said? 37. That was your question. A to the fourth minus t to the fourth is equal to 6a to the second t, and then they say they want you to find dA dt. So what that really means is every time you're going to see an a, you're going to treat that like a y. Every time you see a t, you're going to treat that like an x. And everything else is a constant. So what's the derivative of that? Oh no, so that's y. So I'm going to get 4a to the third times a prime, or dA dt. Okay? Minus. Take the derivative of that, which is 4t to the third. Okay? Is equal to 6 product rule. First times the root of second plus second times the root of the first, 2a dA dt, or a prime, either one. Okay, so let's clean this up. I get 4a to the third dA dt, okay, minus 4t to the third is equal to 6a squared plus 12at dA dt. So I have a dA dt here, dA dt there. Okay, I'll wait till you stop packing up. Thank you. I'm going to take this to the right, take this to the left, and factor out a dA dt from both of those. So when I factor out dA dt, I'm going to get 4a to the third minus 12 minus 12at, and then that's equal to 6a squared plus 4t to the third. So my dA dt turns out to be 6a to the second plus 4t to the third. All that's going to be over 4a to the third minus 12at, and that is my derivative. Alright. Again, let me remind you, you need to do these related rate problems on your own.